NASA said the flares, which left the sun on Tuesday, could cause the largest solar storm in 5 years. It could also lead to the famous Northern Lights being easier to see in some parts. Well, David Whitehouse, author of The Sun, a biography, with me here in the studio. Should we all hide under the table?
Don't need to do that this time. I mean, it was a very large flare compared to what the sun has done in recent years. That's because the sun's been going through a solar minimum of activity. It's building up to the maximum now when we'll see more of these events. And because we're much better at monitoring and predicting these events, we know which ones are going to fly past us and which ones, like the explosion you see on the surface of the sun, are going to send particles, streams of electrons towards the Earth. And it's when they collide with the Earth, and we can predict that now, that they cause all these problems with power lines and pipelines and power grids.
So we did see a big problem back in Canada in 1989?
That's right. There was a particularly large flare then. And because Canada's a northern country, because it's nearer the magnetic poles, and because it has long power lines and long pipelines, which are more susceptible to induced currents when these electrons, which is basically electricity, is coming in onto the atmosphere of the northern hemisphere. That induces all sorts of currents and causes fatigue in power lines. It causes power lines to trip out, transformers to trip out, and it causes pipelines carrying oil to become damaged. We've learnt a lot about how to manage that risk and how to deal with that risk since Canada had a big problem in 1989, as you said.
Okay, so what impact might it have on stuff in the UK?
It might cause some satellite interference. It probably won't interfere with sat-navs, because sat-navs actually get their signal from many satellites, and therefore if one is affected, then you can cope with that. Airlines might have to reduce their transatlantic flights to fly further south to avoid the high levels of radiation, but it remains to be seen. This wasn't a spectacular flare in terms of what the sun could produce. It really is just limbering up to the next solar maximum and showing us that we're actually quite good at predicting these. We're actually good at predicting the ones which will miss us and the ones which will hit us. And we're much better prepared these days, but the sun is always surprising us. Every time we look at the sun, we always discover new things. So it wouldn't be unusual for the sun to cause more damage than we thought.
Okay, however, if you're that way inclined, you can head out tonight to look at the Northern Lights, and if it's reasonably clear, you might see something pretty spectacular.
Well, this is a good side of this, in the sense that these particles are electrons from the sun, and when they strike the northern parts of the atmosphere near the Arctic, they cause the atmosphere to glow in green and red and blue curtains of light that actually move around, as if you like the stream of particles moves around when it's hitting the Earth. And they're unpredictable. The number of times an astronomer will say, go out tonight and you'll see the Northern Lights, and you don't see anything, gives them a bad reputation. So you can't really predict these. It's likely you'd see Northern Lights tonight from Scotland and possibly further south than that. But if you put up with the unpredictability and you do actually catch a show, then the light of the Northern Light is like nothing else in the sky. It is beautiful.
We were going to do the weather, but you know what? We're too fascinated in this, so we biffed that. Tell me some facts that we never knew about this solar energy in the minute that we've got left.
Well, these explosions on the surface of the sun, which you can see one there, that was observed from a monitoring satellite closer to the sun than us, give off more energy than mankind has ever consumed in our history, and probably will ever consume in the next 10,000 years. And the particles from those explosions fly out into space, traveling at 1 million miles an hour, and take a couple of days to reach us. Wow. So when you see the Northern Lights ripple, the green curtains in the sky, that light originated 93 million miles away on the sun.
Wow, that's fantastic. Thank you so much for joining us, David Whitehouse. It's always great to see you. Thank you. Just goes to show that